Let's take a look at Chapter 5 Extra Practice to review Chapter 5 so we make sure we're ready for our test. Now, the main focus of Chapter 5 was factors and multiples. So first we're going to review what is a factor and what is a multiple so that we have a really good understanding of what factors and multiples are. Okay, so let's take a look at both of these. Factors and multiples. A factor is a number that we can multiply to get a product. And the product that we're given is the number that we're trying to find the factors of. So, one important part about factors is that they are smaller than our number, or they can be our number, but they cannot be larger than our number. That's a really important thing to remember about our factors. Now let's take a look at multiples. Multiples are the result of multiplying a number by another number. And when we think about multiples, the important thing that we need to think about is that multiples are going to be larger than our number. And when we think about multiples, lots of times we think about skip counting. Let's take a look at the same number, and we're going to look at the difference between when we find the factors of this number and when we find the multiples of this number. So here's our number 8. And the first thing that we're going to do is we're going to find all of the factors of 8, and that's going to be in blue. So I'm going to write factors next to this. We're going to find our factors of 8. When we find our factors, lots of times we start with 1. And we have to think 1 times what gets us 8. We know that 1 times 8 gets us 8, and that's a factor pair. Now, we have to think about all of the other numbers that we can multiply times something in order to get us 8. It's really easy when we're doing our factors to go in order and say, okay, is this number divisible by 8? Is this number divisible by 8? How about this one? How about this one? That's a good way for us to think about our factors. So, since we started with 1, we'll go to the number 2. Does 2 go evenly into 8? Well, because 8 is an even number, our answer is yes. So we have 2. And now we have to think about, well, 2 times what gets me 8? 2 times 4. So there we have another factor pair. Now, I'd go to 3 and say, is 3 a factor of 8? Can I multiply 3 times anything to get me 8? The answer is no. My divisibility rule for 3 says if I add the digits, so if I find the sum of the digits, that sum has to be divisible by 3. 8 is not. So 8 is not divisible by 3. I'd go to 4, and guess what? My factor pairs, once it wraps around like this, I start at 1, and then I find my factor pair, and I start to wrap around to the second digit, that tells me that I'm done factoring. So I'm going to take these factors and I'm going to put them in order from least to greatest, and this just gives me a good idea of what numbers I'm dealing with. So I have 1, 2, 4, and 8. All of these are factors of the number 8. Now we're going to take a look at our multiples. Now when we're finding our multiples, we're basically taking our number that they give us, in this case 8, and we're going to multiply it times 1, then times 2, then times 3, times 4, times 5, times 6, times 7, times 8, and we could go on and on and on and on and on with our multiples. We're just going to do a few of them. So we're going to start with 8 times 1, which is 8. 8 times 2 is 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. 8 times 6, 48. 8 times 7, 56. 8 times 8, 64. 8 times 9, 72. And then 8 times 10 is 80. Now, when we look at these numbers that we just wrote down for multiples, we see that, well, we're skip counting by 8. We're increasing by 8 every time. I want you to take a look at the difference between our factors and our multiples. Notice our factors are either our number that we're starting with or smaller. Our multiples are either the number that we're starting with or greater. That's the big thing that we got to think about when we're finding our factors and our multiples. Helps us remember which is which. All right, let's take a look at your extra practice practice page that's in your packet. 5.1 was all about factoring out numbers. So we needed to find the factors for these numbers. And we talked about how you can create an array to show you all of the different ways or all of the different factor pairs that you can use in order to find this number as a product. If we start with 17, we'll remember back to when we did our prime and composite number lesson that 17 is a prime number. And we know that prime numbers only have two factors, 1 and itself. So for 17, if we were to draw an array, we would only draw it one way. We'd have 1 here, and we'd have 17 here, and there'd be no other way for us to draw our array. So our factors for 17 are 1 and 17. Now 42. 42 is going to have more factors than just 2. It is a composite number. 42 is also an even number. And all of our even numbers are going to be divisible by 2. So let's start factoring out our number 42. We're going to think about all the ways that we can get to 42. And I'm going to write all of our factor pairs first. So we can always start with 1 and our number. Then because 42 is even, it's divisible by 2. Then we have to think 2 times what gets us 42? 21. Our divisibility rule for 3 said if I add my digits, so I find the sum of my digits, that has to be divisible by 3. 4 plus 2 is 6. 6 is divisible by 3, so 42 is divisible by 3. 3 times what gets me 42? This is where I might have to divide. 3 times 14. Our divisibility rule for 4 is a little tricky. It says we have to double our tens place, which there's a 4. So 4 times 2 is 8. And then we add our ones place, and we get 10 in this case. Is 10 divisible by 4? It is not. So 42 is not divisible by 4. Is 42 divisible by 5? Our rule for 5 says if the number ends in 0 or 5, then it's divisible by 5. 42 does not. So it's not. Is 42 divisible by 6? Yes, it is. Our divisibility rule says if our number is divisible by 2 and 3, then it's divisible by 6. So 6 times 7 gets me 42. And you'll notice once I got to 7 as my number for my factor pair, I have 6. My next number would be 7 to see if it's divisible. It is. I've made my way all the way back around my numbers, and so I am done factoring. I have 1, 2, 3, 6, 7, 14, 21, and 42. Okay, our next number is 28, and we're going to find all of the factors for that. We have 1 and 28. 28 is an even number. So 2 times what gets me 28? 14. The sum of my digits, in this case, I would add 2 plus 8, and I would get 10. That is not divisible by 3. So 28 is not. How about 4? Well, if I double my 10, so I take 2 and multiply it times 2, I'd get 4. And then I add 8 more. I would get 12. 12 is divisible by 4, so 28 is also divisible by 4. 4 times what gets me 28? 4 times 7. It's not divisible by 5. It's not divisible by 6. And I have 7 already waiting for me, so I am done. 1, 2, 4, 7, 14, and 28 are my factors. And last one on this part is 50. I have to find the factors of 50. So I'm going to start with 1 and 50. 50 is an even number, so it's divisible by 2. 2 times 25. The sum of my digits, in this case, 5 plus 0 is 5. 5 is not divisible by 3, so 50 is not divisible by 3. My rule for 4 says if I double my tens and add my ones, that sum has to be divisible by 4. If I double 5, I get 10. and I add 0, I'm still with 10. That is not divisible by 4. I move on to 5. 50 is divisible by 5 because any number that ends in a 0 or a 5 is divisible by 5. 5 times 10 gets me 50. It's not divisible by 6. It's not divisible by 7. Not divisible by 8. Not divisible by 9. It is divisible by 10, but I've already made my way around. So I have 1, 2, 5, 10, 25, and 50. Okay, let's go on to our next step. Is 5 a factor? Our divisibility rule for 5 is, if the number ends in a 0 or a 5, then our number is divisible by 5. So 35 ends in a 5, so yes. 56 ends in a 6, no. 51 ends in a 1, no. 40 ends in a 0, there's my 0, so yes. Then I had to find my factor pairs for these numbers. I always start with 1 in my number, and that's my factor pair. 16 is an even number, so it's divisible by 2. 2 times 8 gets me 16. And then I have to think, is it divisible by 3? No, it's not. How about 4? Yes, it is. 4 times 4 gets me 16. And I only have to write 4 once because it's only counts as one factor. Okay? Next one is 49. Again, I always start with 1 in my number. I have 1 and 49 as factors. Then I really have to think about this. What is the other factor pair that gets me to 49? Is it 2? Nope, it's not even. Is it 3? No, the sum of my digits is 4 plus 9, which gives me 13. That is not divisible by 3. Is it 4? Well, my divisibility rule for 4 says if I double my 10s, so 4 times 2 is 8, and I add my 1s, which is a 9, that then has to be divisible by 4. So 8 plus 9 is 17. That is not divisible by 4. My rule for 5 is above. It does not end in a 5 or 0, so no. It's not divisible by 2 or 3, so it's not divisible by 6. How about 7? 49 is divisible by 7. 7 times 7 gets me 49. So again, I'm just going to put one of those 7s there. All right, here's where it gets tricky. We need to read our word problems and understand what our word problems are asking us. Hannah is putting the fruit she bought into bowls. She bought 8 melons, 12 pears, and 24 apples. She puts the same number of pieces of fruit in each bowl and puts only one type of fruit in each bowl. How many pieces can she put in each bowl? Now, nowhere in this problem does it tell us that we have to use all of the fruit. What it wants us to find is our common factors. If she was separating out this fruit into bowls, how many of each fruit could she put in each bowl? And we want the same amount of each fruit in each bowl. Okay, so we have to find all of our factors of 8, all of our factors of 12, all of our factors of 24, and then figure out what they have in common. So let's do that now. 8, we have 1 and 8, 2 and 4. Those are all of our factors, so 1, 2, 4, and 8. 12, 1 and 12. 12 is even, so it's divisible by 2. 2 times what gets me 12? 6. 12 is divisible by 3 because the sum of its digits is divisible by 3. 1 plus 2 is 3. 3 is divisible by 3. 3 times 4 gets me 12. And I made my way all around my factors, so I am done. I have 1, 2, 3, 4, 6, and 12. Finally, I'm at 24, so 1 and 24. 24 is even, so 2 times 12. 24 is divisible by 3 because 2 plus 4 is 6, and 6 is divisible by 3. So 24 is 3 times 8. 24 is also divisible by 4. If I double my tens place, so 2 times 2 is 4, and I add 4 more, which is my ones place, I get 8. 4 times 6, it's not divisible by 5, so then I make my way all the way back around to 6. And I have 1, 2, 3, 4, 6, 8, 12, and 24. Now I'm going to look at these numbers that I have written in red, and I'm going to figure out what they all have in common. They all have a 1 in common. 1 is always going to be a common factor. They're all even, so they all have 2 in common. Now, while 24 and 12 have 3 in common, 3 is not a factor of 8, but they all have 4 in common. And that's it. 1, 2, or 4. All right, number 2. A store owner is arranging clothes on racks. She has 30 sweaters, 45 shirts, and 15 pairs of jeans. She wants to put the same number of items on each rack with only one type of item on each. How many items can she put on a rack? So she has a choice. In order to figure out how many she can put on a rack, we have to, again, find our common factors. Okay? I have 30. I have 45. And I have 15. We have 1 and 30. 30 is even, so it's divisible by 2. 2 times 15 gets me 30. 30 is divisible by 3. 3 times 10. Not divisible by 4. It's divisible by 5. 5 times 6. And then I'm done. 1, 2, 3, 5, 6, 10, 15, and 30. Okay, let's go on to 45. I have 1 and 45. 45 is not even, so it's not divisible by 2. It is divisible by 3, though, because if I add my digits, 4 plus 5, that gets me 9, and 9 is divisible by 3. 3 times what gets me to 45? 15. It is not divisible by 4. It is divisible by 5. 5 times 9. It's not divisible by 6 because it's not divisible by 2. Not divisible by 7. Not divisible by 8. So I'm done. 1, 3, 5, 9, 15, and 45 are my factors. And now on to 15. I have 1 and 15. It's not even, not divisible by 2. It is divisible by 3. 1 plus 5 is 6. 3 times 5 gets me 15. And it's not divisible by 4. 1, 3, 5, 15. And I'm going to circle what they have in common. They always will have 1 in common. They all have 3 in common. And they all end in 0 or 5, so they all have 5 in common. And that's it. And this one should be pieces. Okay, next page. Is a number a multiple of 9? So I have to find my multiples of 9. 9, 18, 27, 36, 45, and none of my numbers are greater than that. So now I just have to look at what I wrote here and say, is this a multiple of 9? No. Yes. Yes. And no. Easy peasy lemon squeezy. Next one, I'm listing the next 9 multiples. So I got to skip count 9 times. 4, 8, 12, 16, 20, 24, 28, 32, 1, 2, 3, 4, 5, 6, 7, 36, and 40. Multiples of 5, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Now it says, what are their common multiples? Well, what do they have in common? 20 and 40. Same thing for the next one. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Now 6 is 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. What do these have in common? 12, 12, 18, 18, 24, 24, 30, 30. Hey, this is strange. Look, I have 12, 18, 16, 12, 18, 24, 30, and 6 that I all have in common, and they're all in a row. Why do you think that is? Because 6 is a multiple of 3. So because 6 is a multiple of 3, I'm going to overlap with all these. So my common multiples are 6, 12, 18, 24, 30. And if I kept going with my multiples of 3, I would keep going with my common multiples as well. All right, last section. Tell whether the number is prime or composite. A prime number only has 2 factors. A composite number has more than 2 factors. Okay, so let's look at 39. Well, I see a 3 and a 9 here. I know both of those numbers are divisible by 3. When I add them up, I get 12, and that is divisible by 3. So this number is composite because it has more than just 1 and 39 as a factor. Okay, 29. Well, it's not even, so it's not divisible by 2. When I add the digits up, I get 11. That's not divisible by 3. If I double my tens, that would make it 4. 4 plus 9 is 13. That's not divisible by 4. It's not divisible by 5. It's not divisible by 6. It's not divisible by 7. Not divisible by 8. Not divisible by 9. And not divisible by 10. It's going to be prime. 51. It's not even, so it's not divisible by 2. If I add my digits, so 5 plus 1 is equal to 6. That is divisible by 3. So 51 is divisible by 3. So because it has more than just 1 and 51 as factors, it is a composite number. Last section. Our rule is to add 6, and our first term is 10. That means that's where we're starting. 10, add 6, 16, add 6, 22, add 6, 28, add 6, 34. Add 6. 40. 46. 52. And it's asking for the first 12, so you can finish those. I did 8 for you. Now, it says describe another pattern in the numbers. What else could you tell me about these numbers other than we're adding 6? You could tell me that they are all even. You could show me a pattern in the ones place. I go from 0, 6 to 8, 4. 0, 6 to, I'm guessing the next one's going to be 8 and then 4. And then 0, 6 to 8, 4. So there's another pattern. You could tell me a pattern in the tens place. There are lots of different patterns that you can find. Last one on the bottom. The rule is add 3, subtract 2, and I have to start with 7. So 7, add 3, 10, subtract 2, 8, add 3, 11, subtract 2, 9, add 3, 12, subtract 2, 10, and you would go on and on and on and on with this until you get to the first 12 numbers in the pattern. Then you're going to look at this pattern and tell me something about it. I see even, even, odd, odd, even, even, odd, odd, even, odd, odd. See if you can find a different pattern. All right, that should help you review for Chapter 5. Remember, we're talking about prime and composite numbers. We're also talking about multiples and factors. When we find all of our factors, please make sure you find all of your factors. Don't rule any numbers out. When we're finding our multiples, remember, those are going to be larger than our number that we're given. Our factors are going to be smaller than. But the one thing that factors and multiples have in common is the number that we're given is always a factor and it's always a multiple.